Hi, welcome to the Fossul framework. Today we're going to be looking at application consistent backup and recovery using the Kubernetes Container Storage Interface, CSI. My name is Keith Tenzer. I have 20 plus years of experience in various roles. I have a blog, keithtenzer.com, and I've been at Red Hat since 2015. What we've configured is we've got a Mariadb database running on OpenShift, which is Red Hat's enterprise Kubernetes distribution, backed by Ceph storage. A quick overview of CSI. I'm sure all of you are familiar with CSI in the context of provisioning and deprovisioning. So Snapshots is fairly new, or it's newer. It's still in the alpha stage, but it's definitely coming and evolved significantly, which is why I'm showing all this. And basically similar to a storage class for provisioning and deprovisioning, you have a snapshot class, and a snapshot class defines a snapshotter. In this case, we're using Ceph, so it'll be Ceph RBD. And the snapshotter creates in Kubernetes and OpenShift volume snapshots, which are objects, and they have contents as well, and they basically map to a physical snapshot on the storage system, in this case, Ceph. The beauty here is we're exposing now basically storage vendor features and capabilities like snapshots, which enable backup and recovery, and doing it in a way that we can follow the same backup and recovery process, and we don't have to integrate with the storage vendors separately, but rather they can do so themselves through a driver. So a quick overview on Fossul before we get to the demo. Fossul is a container native backup and recovery framework. Fossul has basically three services. There's a server service which basically provides an API. It handles a job scheduler. It handles running workflows and metadata, all those kind of things. The application service exposes application functionality. So this is similar to the idea with the CSI driver. It exposes application functionality around backup and recovery through plugins. So in this case, you have a Mariadb plugin. It tells Fossul how to do backup and recovery operations for that database. We also have a storage service which does the same thing for storage. Of course, we have CSI, so we have a generic way of integrating. However, not everybody integrates with CSI, and there's also lots of different types of storage vendors and integrations, if we think of archive and things like that, where plugins may be very helpful there as well. So it's a full plugin first framework for integrating with applications and storage. And Fossul views the world through the eyes of a workflow. So in this case, we have a backup workflow. There's also a restore workflow. We'll look at the backup workflow. It defines a series of steps. Basically, each step is implemented in a plugin and executed in a plugin. So the ones in pink are application. They're executed and implemented on the application service. The ones in blue are on the storage service, and the ones in are storage plugins on the storage service, and the ones in green are archive plugins also on the storage service. So if we're the user here and we execute a backup, which we'll be seeing shortly, the first thing it's going to do, it's going to talk to a database, in this case Mariadb. It's going to execute the Mariadb plugin, and it's going to bring Mariadb into a application consistent state. Once that's achieved, it's going to talk to the storage plugin. In this case, it's going to be CSI, which is going to be interacting with Ceph, and it's going to create a snapshot, which is application consistent because the application is in a backup state. Once we have the snapshot and the backup is complete, we can then unquiesce and bring Mariadb through the plugin back into its normal state of operation, and we have a backup. We've successfully completed a backup. Optionally, Fossul can also mount that snapshot and archive it, say, to the cloud, and then clean up, unmount the snapshot. We're not going to see that in this demo, but those capabilities are there. So let's get to the demo. I'm going to show you what I have set up here. The first thing, we'll go into OpenShift, and we'll look here. We have a OpenShift storage project. So we're actually running Ceph through Rook. This is OpenShift container storage in 4. We're using this to deploy basically Ceph inside containers on the platform itself. So this is where our storage is coming from. Then we also have Fossul running, and here you can see the three services. There's the server service, the app service, and the storage service. If we if we go in here, you see there's also a route, so we can actually connect to the Fossul API. So Fossul provides its own API. You can see here it's using Swagger, so there's the API documentation here. The nice thing here is we can even execute APIs. So if Fossul has its own scheduler, it's one of the features built in. So if I want to list the schedules that exist, I can just basically try the API, execute it, and you can see I get a result back here. So we can see we have for our Mariadb database, I'll show you briefly how we configure that in Fossul, how we configure the backup, but we have a schedule running every 30 minutes on the hour. So we have that, and then the last thing is the databases. We have a databases project, and here's actually where our Mariadb database is running. So we can go in here, look at the deployment, we can see we have a pod that's up and running. And if we go into the database, and I'll just connect here, we can connect to the database, which is called SampleDB. I've created a table called authors with some data in it. So we're actually going to back up this data consistently using Fossul and the CSI driver, and then we're going to delete it and restore it. That's basically what we're going to go through. Now. So let's go to the CLI, and I'll show you how we've configured actually Fossul. So we can start there. The first thing we can see here is the schedules. So again, we showed this using the API directly, but basically we can see here talking to the scheduler component, we have a backup schedule. In Fossul, you have a concept of a profile and a config. So basically a profile is simply a group, and a config is actually a backup configuration. So each application is going to have its own backup configuration. However, an application could have multiple backup configurations, or there could be a group of applications that we're interested in, each of them having their own. And in the backup configuration, we define a policy. In this case, we're using a policy called daily. So now I'm going to show you how to actually create a backup configuration. We already have a backup configuration here, so I'm just going to basically download it or show it. So the backup configurations are all key value pairs, so they're basically flat files on the Fossul server. And basically all you have to do is go in here and configure, well, first you have to configure, is Fossul running inside of a Kubernetes cluster or not, because Fossul can actually run outside of a Kubernetes cluster. It's up to you how you want to run it. You configure an application plugin. So in this case, we have mariadb.so. You configure a storage plugin. You have CSI-ceph.so in this case. And Fossul comes with a whole bunch of plugins as well. So you can choose what plugins you want to use, and you can write your own plugins as well. And we configure a job retention. So this is not the backups, but every time a backup is run, there's a workflow, and it basically has, it's logging associated with it, what happened, all of that. So we're retaining 500 for this specific application's backup. And then the only thing you really have to deal with, optionally there's these pre-post commands. So this is another area you can integrate. So you remember in the backup workflow, there's all those steps. Every step has pre-post commands, and you can basically fire commands or scripts here to interact with the backup. You can obviously do this through plugins, or in this case, generally you don't need it. You can just use plugins, but there's a lot of capability and flexibility here. Then you configure the backup retentions. This is basically a retention daily. 3, we also configured one weekly. With 3, we're not using it, but we could create backups against that. And then for archive, you also have various retentions. Again, we don't have an archive configured. So that's what that looks like. Then the plugins each have their own configuration. So if I do get plugin and I give it a plugin, mariadb.so, you'll see here, this is for the database, so what namespace it's in, what's the IP of the service, how to connect to it, that kind of stuff. That's what's in that plugin. And the CSI-Ceph plugin, we can look at that, is basically going to have, the name of the backup, where the namespace is for Ceph, the Ceph pool, PVC name, snapshot class, snapshot timeout. So this is kind of important. Actually, what we're doing is we're actually polling because if the snapshot takes longer than 10 seconds, we fail it, and we then return the application back to its state. So again, this is why you need sophistication, and why Fossil is really good, is because applications, a lot of times backup mode is read-only mode. So you're not able to write to those applications while they're in their backup state. And so you really want to control and ensure that they're only going to be in that read-only state for a certain period of time. And if the snapshot times out or something, you could be in a very bad situation. So that's after 10 seconds, regardless of what happens, we bring the application back to its proper state. So that's what the plugins look like. So now what we're going to do is we're going to actually show the backups that we have. So we can give it a policy here and give it an action backup list, and it's going to basically show backups. Again, we'll only ever see 3 here because our policy is retention 3. And you can see we have a couple here. You see the name of the backup, you see the policy, and you see the workflow ID that generated that. We'll come to that later. It's important. The workflow IDs are important in Fossil. So we'll show that why that is in a second. And so now what we're going to do at this point is just create a backup. So I'm going to create a manual backup here, and we'll walk through it. So you can see the first thing that happens is it generates a workflow ID. In this case, it's 9702. Then it goes through and it does application discovery. So it's going to then talk to the Mariadb plugin. It's going to discover what it needs. In this case, it needs to know the location of the data directory where the data files are stored. It's going to then quiesce the Mariadb database through the Mariadb plugin. It's going to flush the tables with a read lock and flush the logs. This is how you do it for snapshotting. And again, each plugin that you have defines what happens here. So you have a lot of flexibility. Once the application is in a backup state, we can perform the backup. And here we're using basically the CSI snapshot and creating a snapshot based on the PVC, and that's all happening through the CSI driver and the CSI plugin on Fossil. And once we have our snapshot, then we unquiesce it. Again, talking to the Mariadb database, unlocking the tables, and then we go back to the storage plugin to perform backup retention. As you saw, we had three backups. Once we created this, we had 4, and we're only supposed to have 3, so we delete the oldest backup basically. And then we don't have anything for mount archive because we're not backing this backup up to archive in this example. But if you did, you would have those kind of things. You can also send notifications out if the backup's completed or failed. Or what have you. So now if we do a backup list, basically, we can go in here and we can see the backup. And so remember, our workflow ID was 9702, and 9702, this is the one we just created. So Fossil also provides, we saw in the configuration there was a job retention. So you can say job list, and you can see all the jobs that ran over Fossil. So you can see if they completed or if they failed, if they were backups, if they were restores, what their workflow IDs are. So the workflow IDs are important because when we want to fetch the logs for backup that already occurred, we need the workflow ID. So if we want to look at this backup that completed, I don't know, 7480 a while back, we can do job status, and we give it the workflow ID of 7480, and it's going to fetch this backup job basically from the server, and basically so that's what we have there. So now I would like to show you how all of this stuff maps back to Ceph storage. So if we do a OC get PV here, we can see the persistent volumes. So here's our Mariadb database. You can see it has a PV, and if we look inside of this PV, there will be what's called a handle, and with that we can actually figure out what volume the PV maps to. And I'm looking for right now the command. Here it is. You can see this. This is the PV here. So we're basically going inside of the PV and pulling out the handle, and then substituting the front of it CSI volume, and we're putting it out. And this is basically how we can get the Ceph volume. And so When we look on the Ceph side now, if we go over here and I can just look at my Ceph volumes, you can see right here, this is actually the volume that Mariadb database is being backed by. So, and we also, now that we created a backup, we created a volume snapshot. So again, this is because the CSI driver, it's integrated with Kubernetes. These are actually the backups as they see. You can see from our backup here that we created this one right here, 7480. You can see it right here. This is actually in Kubernetes. So I can actually get this and go in here, and we can actually find out what how this volume snapshot, to what Ceph snapshot it maps to, right? So if I look inside here, we will get the snapshot contents. And the snapshot contents is basically what is contained inside the snapshot. In this case, it's going to be actually the snapshot itself. And so what we're going to do now is we're going to do a OC get snapshot volume snapshot content, and we're going to give it this content name here, and we're going to look at the YAML, the output of that. And here basically you can see this handle, and this is the same thing with the volume. It puts kind of this part in front, but this is actually what it uses. It strips this off. Actually, this is actually what's used for the snapshot name. So our snapshot, our actually Ceph snapshot, is going to have CSI-snap and then this name. So now if I go back to Ceph and we look here, we do a snap ls for our volume here and run that, we will see essentially this. I'll copy paste this so it's clear here and just paste it in. So we can see right here, this is our snapshot that got created. So it takes this ID and does CSI-snap in front of it. So that's actually on the Ceph, the physical snapshot that get generated through Fossul through the CSI driver and all that stuff. Okay, so now that we've seen basically creating a backup, how all this stuff maps back, let's actually do the most fun part, which is a recovery. So again, we have our authors here. I'm going to come in here and I'm going to say drop table authors, and now the data is gone. So I've created a restore scenario, essentially a logical corruption, if you will, and the data is gone, right? So now no problemo. That's why we have Fossul. So now what we can do, again, we'll go back here and do the backup list and just get our look at our backups again before we do the restore. We obviously need, for the restore, we need the workflow ID. So I change the action to restore and I give it a workflow ID. And again, our backup was 9702. If I go all the way back to our backup configuration here, the backup ran, you can see it's 9702. So that's great. So 9702, and off we're going to do the restore. So now what happens is it's going to actually shut down the database. You can see I lost my connection here. And if I go in to the deployment configuration here for this database, you can see here it's scaled it down to 0, and it's in the process of scaling it back up. But if I go back here and you can see what's happening, it's going to actually start the restore. It's going to start. Obviously, every backup or restore is a workflow, so it has a workflow ID. You saw why that's important in the job monitor and stuff like that. It's going to scale the deployment to 0. It already did that. Then it's going to do that using the Mariadb plugin. So again, the database is responsible for deciding what happens when restore. Should it be shut down? Should it not be shut down? What should happen? How should I prepare it for that? In the case of Mariadb, you definitely want to shut it down before you do a snapshot restore. And then it goes to the storage plugin to do the snapshot restore. It's going to do basically roll back that snapshot. It completes here. We see that it's completed successfully. And then it goes back to the Mariadb plugin to scale the deployment. And again, it's going to wait until the deployment is scaled to 0 before starting the restore, and then wait till the deployment is back up and running. And you can see in this case, it's back. So now if I go back to my database, sure enough, it's here. And if I now go into that database, it might take a little bit to connect here. No, it's pretty quick. And we connect to the database itself. Now I should be able to select star from authors, and boom, my data is back. And that is just how brilliant and amazing this is, and how simple it really is. And this is the user experience, the application user experience that Fossul aims to achieve. So there's a community for Fossul. It's in GitHub. Actually, I didn't show that, but it was worth showing. So basically in GitHub, basically there's Fossul, and if you go into Fossul, that's the main repository here. There's a lot of documentation on how to get going, how to use it, contribute, all that good stuff. So definitely join the community. There's a link again. And thank you for your time. Appreciate it. Hopefully you saw the need for application-centric backup and recovery. It's not about the entire cluster, and it's about the applications. And when we're talking about the applications, it's very important to do things, quiesce them, unquiesce them, and the recovery steps and all of these things in an appropriate way if you want to have guaranteed successful backup and recoveries, which of course you do. So thank you for your time. Hope this was interesting, and I look forward to your feedback.